All right, this looks like question 3e. Let me just check that actually. Is it 3e? I think it's 3. It is 3. Okay, fine. All right, so now the question asks, a chemical is dropped into the water in a rectangular swimming pool at a halfway point along its length. After 0.1 minutes, the chemical spreads in a semicircular shape with radius r meters, where r is 1 plus 2t, t being time. T is the time in minutes since the chemical was added to the water. When the chemical first reaches the far side of the pool, so it's going to radiate like this until it gets to the far side, the area of the semicircle is increasing at a rate of 60 square meters per minute. And we have to find the width of the pool given that this is the situation. The width meaning this amount here, yeah? That's W there, that's the width if you like. But we can work out the width because we know how long it's going to take to reach the other side of the pool, and based on the fact we would know the area of the pool. Because we do have an equation for this. You see, we've got area of a circle is pi r squared, but of course this is the area of a semicircle. So I'm going to write area of a semicircle. In fact, here we go. I'm going to write area. I'm going to put a little, not a circle, but a little semicircle there, is equal to, and it's going to be pi r squared on 2. Now, what does r equal? Well, here it is here. R is 1 plus 2t, and it's just a matter of substituting one to the other. Then we're going to differentiate to find the rate of change of the area. All right, so let's go ahead and do that. So area, therefore, will equal pi on r squared. And r is being 1 plus 2t, so it's going to be times 1 plus 2t. In fact, I'm going to write it out twice, 1 plus 2t, because it's squared, yeah? And it's over 2, and I'll just put the 2 bit over there. That makes sense. All right, let's expand all this out. So it's going to be pi on 2 times, well, 1 squared is 1. 2 squared is 4t squared. And I've got a 2t and another 2t. It's going to be plus 4t. Yeah? So that in itself looks pretty good. Let's expand this out now. So that times 1, well, that's just going to be pi on 2. Pi on 2 times 4t is going to be 4 pi t on 2. And pi on 2 times this is going to be 4 pi on 2t squared. So that all makes sense too. Now I've got a few 2's on the bottom there that we can get rid of those. So this is going to be pi on 2, plus this is going to be 2 pi t, plus this is going to be 2 pi t squared. All right, now that's area. That's what the area equals. We want to now find the differential of that to find the rate of change in the area. So let's change area, find the change in area with respect to time, because we want to find the time it takes for the to reach the far side of the pool. Yeah. All right, so here let's do that now. And if we find that, we can take that time and plonk that straight back into the equation here to find r, yeah, which is going to give us the width of the pool. All right, let's have a look at that now. So we've got pi on 2, but okay, this is with respect to time. Well, of course, this is actually to the power of t to the 0, which of course 0 times all that makes that 0. So I've got a 0 plus, this is 1. 1 times 2 is 2. And that's going to be 2 pi. The t falls away because it's now to the power of 0. And then I've got plus, this is going to be 2 times 2 is 4 pi t. And that's all I've got. Now we also know, though, that this is increasing at a rate. We actually know the rate of increase. The rate of increase, we're told, is 60 square meters per minute. So I can go, because this is area per time. This is square meters per minute. So I can actually just substitute for that the 60 square meters per minute. So let's plonk that in there, 60, and that's equal to, and I don't need the 0 anymore, but I can go 2 pi plus 4 pi t. So I want to find out what t is. So let's make t the subject. So I'm going to subtract 2t from both sides, minus 2t. Here it is. So 60 is equal to 4 pi. Oh, wait. Well, I better do that properly. Right. Yeah. Okay, so I'm being a bit hasty there because I've got to write all these digits. In fact, tell you what, here we go. Let's do that like this. So I've got 60 minus 2. So I'm right in one go going to also divide this by 4 pi and all of that by 4 pi, and that will just leave me with a t, yeah? So t, therefore, is equal to all of this. So let's do that now, and let's see where that takes us. So I've got a 60 minus 2 pi, there it is, and I'm going to divide it by 4 pi. And I get 4.27 and change. Well, I'm going to write it all out because we're going to use pretty much all of that, I imagine. So 4.27, 2648293. So that's good. Dot. So that's the time in minutes. Yeah, put mins. Yeah, these are time in minutes. All right. Well, let's put that back into the original equation here, and that's going to give us r, the width of the pool. All right, here we go. That's what we're after. So I'll put sub t into r equals 1 plus 2t. That's what we're wanting to do. So r, therefore, is going to equal 1 plus 2 times this thing here, which is 4.272648 ... I'll put. And r is equal to, and I've kept the number on the screen here, so I'm just going to go 2 times that. So it goes times 2. Be nice if it was in focus, right? There, you got that. 2 times that plus 1 is, and we get 9.54929. Okay, so let's write that out. So it's going to equal 9.54929 ... But now let's do it to 3SF, yeah? So what we'll say is, therefore, r, the width of the pull, is going to be 9.5, we're going to call that 5.5, right? 5.5. Now, the r is going to be in meters, yeah? And I'll put 3SF. So therefore, the width of the pool is 9.55 meters, 3SF. And that would be how I find my answer.